think of air having pressure because of the fact that the air inside of our bodies and the air outside of our bodies is at the same pressure. The air flowing around the outside of this ball is increasing in velocity due to the shape of the ball. Air has mass, air has volume, air has pressure, and air is affected by temperature. Well, my name is Jack Gilbert. Today I'm here talking about Mechnet Incorporated. What we have done with Mechnet is we've taken our extremely expensive lab equipment that we build for primarily four-year universities, colleges, research institutions, testing companies, things of that nature. And what we've done is we've created a system as to where any student in any school can be able to operate that equipment remotely via the internet and have almost the identical experience as operating that equipment as if it were in the same room as the student, by use of video cameras so the students can see airfoils rotate in the airfoil and tufts move and things like that. And they can operate the airfoil, change the velocity of the wind tunnel, everything exactly the same as if the computer program were in the same room. What we've done is we've reduced the cost. And one other strong point about Mechnet is we have a real good chance of putting a real good, strong STEM program for the underserved, underrepresented students in the inner city. A lot of them don't get the good quality STEM education that your suburban schools get. But by using this method of the blended learning, media-rich lessons, and the remote operation of the equipment, what we can do is we can allow an inner-city school student to have the same experience as any student anywhere. And that's a very important thing. One thing that we did not mention before, and is a very important aspect of the remote blended learning model, is that we can very easily put this program into hundreds of schools. Say, for example, if there's a charter school system with 100 to 200 schools in that charter system, we can put the exact same aeronautics program into all of those schools without each individual school having to purchase the equipment. One of the big advantages of what we're doing is we're having the students use real data. This is not CFD or computer generated data or anything else. This is real data from real experiments. And what this does is this allows the students to do all the math formulas associated with that data. So essentially what happens is there is a real purpose for doing the math formula. It brings the math to life. Now, every letter in the equation relates to something real. And like I said before, there's a real purpose for doing the math formula. And with the fact that we're using research grade quality equipment, our data is accurate enough that we have less than sometimes a 1% error in the data. So now, with the data being that accurate, we can take that data and put it in the math formulas and do the math formulas and have them come out correctly. What we have done now is we've created what is called recorded data experiments. What we did is we have run a wind tunnel and recorded the data at each velocity with each angle of attack, and then stored all of that data, and then created a program from all that stored data that allows the student to manipulate the software and see the data in the exact same fashion they would if they were actually operating a piece of equipment. This will allow us to get the cost down to essentially software level cost or a basic seat license fee per semester, which will reduce the cost much lower than even the remote operation of the equipment. Going forward, what we're looking for is the remote operation of the equipment will be used a lot. Like, say, for example, we're working on a program where students will be able to print an airfoil for a small RC airplane with a 3D printer. That's another thing now, too, that has greatly enhanced our program is the strong advancements we've had recently with the 3D printers. Students can very quickly make a model, a very accurate model, and do that. Like, say, for example, with the airfoil for the RC airplane, what we're looking at doing is having the student design their own airfoil and then send us the profile. We will print the airfoil and then mount it in a small wind tunnel. They will operate the wind tunnel remotely and get all the data from their airfoil. So in that fashion, what we're looking to do is use the remote operation of the wind tunnels more for students doing testing of things that they have sent us, which actually is the way big companies do things. Most big companies don't own their own wind tunnel. If an engineer needs to do something, they send it to a wind tunnel company and they mount it in one of their wind tunnels and they pay so much per hour to have it tested. The remote operation of the equipment is very similar to when computers first came out. When computers first came out, they were so big and expensive that very few companies had their own computer. So what they did is they created what was called a time-sharing program, where a great many different companies could operate the great big computer and get their data and everything else. Well, that's almost the exact same model as what we're doing now with this research equipment, is we're allowing all the schools to operate it. Right now, we're using all of the equipment that we have designed and developed by GDJ. We use a lot. There is a lot of work being done with the wind tunnels. That's our initial product. We also have a single-cylinder engine that can be operated remotely, and we designed our own fuel injection system for the single-cylinder engine, which allows the student to remotely change the mixture and see the effects of exhaust temperature and things like that, and horsepower on the engine. There's dynamometers on the engines and things. And then we also have a 4-cylinder Honda engine, which is has the capability of being operated remotely. And then we're just finishing up now what we call an auxiliary power unit from a Boeing 727. What this is it's a Garrett GTCP 85 APU. This is the engine you hear running in the back of the airplane when you first get on the airplane. You hear the engine running in the back. It's running a generator and the environmental system on the airplane. Well, we have that mounted to a test stand, and what we did is we removed the generator and we replaced it with an eddy current brake. This allows the student to load the engine. The governor on the engine maintains the engine at 41,000 RPM, but what the student sees is the increase in fuel flow, the exhaust gas temperature, and things of that nature. That engine allows the students to see all the different parameters and everything else. One big advantage of operating the turbine engine remotely is that even if a school can afford a turbine engine, a lot of times there's real environmental problems with the noise created by a turbine engine, of having them even on a college campus run while there's classes going on and things of that nature. And it's another one of those things too, is that the students only need the engine for a few hours per semester. And we've even got one of the societies that currently certifies the mechanical engineering programs that has told schools that if they operate the engine remotely, as long as they're operating a real engine at the other end, that they will give them credit as if that engine were sitting in their facility. What they do is they consider it a engine test cell with a 1,000-mile cable. With the 2x7 wind tunnel that we saw in the video today, we developed that wind tunnel specifically for that purpose of being able to observe the airfoil physically lift in the wind tunnel. Most wind tunnel experiments are done with the airfoil static and being held in one place and rotated. This allows the student to actually see the airfoil fly in the wind tunnel, see the airfoil physically move. Anytime students can actually see things happen, that's a big enhancement. And we are able to achieve speeds of over 100 miles an hour in that test section, in that wind tunnel. One of the things we're able to do now with Mechnet is take advantage of a lot of the recent advancements in AutoCAD animations, graphical interface software programs, data acquisition systems, and things like that. A lot of the speed of the internet. What we're able to do now with remotely controlling a piece of equipment over the internet, we could not have done 10 to 15 years ago. Now we're talking, speeds that just weren't obtainable years ago. So now, between the speed of the internet, the advancements in software, the advancements in data acquisition systems and things, these have all made what we're currently doing with Mechnet possible. What this is one of the magazine articles that did a story on what we were doing with the remote operation of the wind tunnels. They said it was a 21st century education for the 21st century student. And that's essentially what we're doing is we're taking advantage of a lot of the recent advancements in all these systems to provide an educational model for the students that just wasn't capable a few years ago. Recently there was a show on education by John Stossel, and on that show they interviewed Bill Gates and some other things and stuff. But Stossel said something that was extremely interesting to me. He said that years ago, when you wanted to see a band play, you went to the local town square and you listened to the band play. Now you have phonographs and CD players and everything where you can hear music being played by professionals. Well, it's the same thing now with these blended learning classroom models. We have access to all sorts of resources and equipment and everything else to produce a very, very good blended learning class model that the average classroom teacher just doesn't have. They don't have the resources to call up someone at NASA and get information on something or things like that. And, so what we're able to do with the blended classroom model is we're able to create a lesson using a tremendous amount of resources available to us.